Hey everybody. So this is Gophers continuing up the iceberg, and I am Matt Doppel. And okay, that shows up correctly on my screen, but that's weird. There we go. Okay. Anyways, so uh just quick, who am I? As I said, Matt Doppel. I am co-founder of a new startup, Columnar. We recently did our whole going live announcement, publicized stuff, and so on, talking about Apache Arrow and AWC data connectivity. But for this talk, I'm more focused on Iceberg. Now, I am a PMC member of Arrow and Apache Iceberg, and also created the Go implementation of Iceberg, which is what I'm going to be talking about. So let's just dive right in. Now, I'm assuming that many of you are probably already familiar with Iceberg in general. So I'm not going to go too deep in the actual Iceberg implementation details or Iceberg information stuff. I'm mostly going to focus on stuff about using it with Go. Now, of course, Java is the canonical implementation of Iceberg. And usually, most people are accessing it through Spark, but occasionally through Dremio and ClickHouse and Databricks and other things too. So why do we care about using it with Go? Well, many people like being able to use Iceberg without a JVM. And this is evidenced by the multiple implementations that also exist via, PyIceberg if you want to go natively through Python, Iceberg Rust, Go. There's even, relatively recent C++ implementation of Iceberg. And all these things all work together, building out implementing the actual spec, working with the community, and integrating with the Iceberg ecosystem and allowing you to utilize Iceberg without needing a JVM and Java and all of the issues that come with it. Because, well, we all know that I will hammer and slam JVM and Java because that's my personal preference, but there are, drawbacks, startup times, memory usage, the whole 9 yards. So of all those different implementations of the different, of Python, Rust, Go, why am I specifically talking about the Go one? Aside from my own personal, I enjoy Go, what's the benefits here? What am I bringing up? And that comes down to, these are all personal opinions, but it does make a difference that, Go compiles native code. Go is also extremely simple and easy to learn. It's designed to be extremely readable and gives you a really easy access to concurrency primitives to make multi-core scaling usage handle so much easier to write than in many other programming languages. And also, Go has become the language of the cloud. It because it always compiles to statically linked binaries, because it gives you this memory garbage collected runtime, but it's still native code, so it's still fast. You end up with it becoming this common factor for how you build services, how you build, like Kubernetes is written in Go, Docker is written in Go. Like all these cloud native applications are all built in Go. And there's also this enormous community and ecosystem of utilities, tools, and libraries that exist, just like many other languages. As for the specific use cases for utilizing Iceberg from a non-JVM context, how about just simple CLIs? If you want a simple CLI for exploring Iceberg metadata and catalogs and grabbing data, grabbing snapshot information, things like that, you don't want to spend and wait for the startup time of a JVM for a CLI utility. You want to have just a single binary that I can just easily distribute, that has no dependencies, that I can just go here, have a CLI. If you want to integrate Iceberg information, Iceberg data into a non-Java language, but you don't want to use JNI, you don't want to use Spark, you don't want to use, some custom protocol, that's another reason why you'd want to utilize a non-JVM library for Iceberg. If you're writing a Python utility, you don't want to have to spin up a JVM just because you want to talk to Iceberg. You want to be able to just use Iceberg natively via PyIceberg. Same goes if you have an existing system written in Go, written in Rust, written in C++, and you want to add support to low-level Iceberg primitives, but you don't want to rewrite the whole application. You don't want to have a bridge to between things. You don't want to shim everything together. Again, while lots and lots of things use Java, not everything runs on JVMs, and you don't want to have to shove things in there if your system isn't already using it. And again, that's the reason why you want to focus on these non-JVM use cases that do exist for many, many people. So let's talk about the current status of the Go implementation. The current status for the Go implementation for Iceberg, we've got we got almost all the operations for the REST catalog are implemented. We've got support for the Glue catalog. We've got support for SQL-based catalog running on SQLite or through a JDB through an ODBC connection or however you want. We also support the various different file system type cloud blob storages. S3, GCS, Azure, local file system usage, the whole 9 yards. We also recently added a full utility for building new metadata and updating just metadata changes if that's what you want to do. We've got read support for schemas, metadata, time travel reads, scans. You want to do a scan plan? You want to actually just stream the actual data out using Apache Arrow? You can do so. Get a stream of data. Very efficient, very useful. We have support for getting the metadata on Iceberg views and getting their definition. We don't execute them yet because we didn't embed a SQL engine because that's silly. But we also have a lot of write support too. You want to create a new snapshot, append data to a table. You want to stream data to a partitioned table. All these things already exist. Doing rewrites, and we're working on adding the support for deletions and other compaction primitive options. And so the roadmap for Iceberg Go, obviously we want to get feature parity with PyIceberg. That's the first thing we want to do. We also want to add support for Hive, DynamoDB based catalogs because, lots of people use them. We want to add, equality deletes, puffin files, compactions, upserts, all these utilities and features that are kind of important for the ecosystem and for most Iceberg use cases. Having simple read and write is great, but you need to be able to handle deletes. We need to be able to handle these things, and those things are in work. And also, just in general, full Iceberg v3 compatibility, the new types, variant, geospatial, all the new types coming in, deletion vectors, all these new features that came along with v3 that we want to add to it. We've got some of the new metadata. And so some of the things that the Iceberg Go library provides is, as I mentioned before, having a CLI. Well, we provide a CLI. You can easily just, get a ton of information from a REST catalog or whatever catalog you like and utilize this CLI and explore your catalog, explore the tables, get file information, get schemas. You can get the schema information and the snapshot list from a table. It's super simple, super easy to manage, to play with. And so what does it actually look like in practice? What does it actually look like interacting with Iceberg tables via Go? Well, if you have a local file system and you want to just point directly at the raw metadata.json file, you can do that. See right here, you can get this nice simple, create your local file system handler and then just create a new table from the actual metadata.json files. Simple. Okay, give it a name, dump the schema, straightforward. Another example, if you want to actually interact with the catalog, you can see here, simple REST catalog interaction using the Iceberg REST catalog interfaces and communication. So this will work for anything that supports the Iceberg REST catalog protocol. And then you also pass it other properties you need for interacting with the file storage. In this case, I'm using the local min.io, but S3 or whatever you want. And you can see that I create the catalog, tell it, it's a REST catalog, give it the credentials for the S3 min.io instance. And then from there, I can just do catalog.load table. I give it the identifier of the table, and I get the table, I get the schema, the location, the prefix location of the table, and everything, all the above, everything you need to actually interact with. And then you can do scans, which I'll show you in just a moment. Because I am going to tempt the demo gods and give a live demo example here. And so what I have here is my lovely instance of VS Code. And I have started a Docker container using min.io, using the Iceberg REST fixture to provide a REST catalog. And I ran a little Spark script to create a bunch of tables to test with. And we can see, we can see here that, we have all our tables, my local host right here. We have all our tables in the min.io storage. And so let's try playing with a scan. Let's test it out. And so if I go to the table and we go to our scanner test, we can see nice, simple, I have my catalog. I initialize the catalog like this. Simple, straightforward, just like you saw in the example. And then we can do some simple scanning tests. We can do, we can just run the simple test. And you can see here, it's going to load the table, plan the files. I'm going to use a tag ref. I'm going to get all this information. And I don't know why it's taking so long. It never takes this long. So what we can do to, see? So I get for tempting the demo gods, right? What we can do is we'll have some more fun. Let's make a new little main prog. Don't knock him over. A little demo main prog. Main.go. So we have a main prog. Let's go ahead. Cancel that. Okay. So we can see here that go back to my test. It's a nice, simple thing. Let's go. We can get our catalog. So we have our catalog. Load our table. Now we saw the tables are named, and we have, identifiers are default, and then the table name. So table.identifier. Default, test all types, So now and then just to prove this all works, we will run our little main prog. So it's going to build it up. It's going to run it. And we can see it load the table. Okay, just to add a little more, let's go with print the table schema. So now we can see it works. Yeah, you can see that there. Okay, so let's have some more fun. Let's have some more fun. Let's see. I have an example here where we have a filter. We have this UID fixed and unpartitioned table. And so first we'll do a scan. Oh, print schema cell. First we'll do a scan. We'll do table.scan. We'll put no filters. We'll get an arrow table. And let's print out the data that's scanning it. So we scan the table. You can see super simple, super straightforward. I mess up here. It's because it's running. MinIO is fun like that. MinIO is mad because it's not using the MinIO URI. So MinIO is mad at me for it. But kind of the point here is showing, just to prove that I'm reading the actual table here, is that we can go with, if we look at ClickHouse reading the same data from the same Iceberg table, you can see the same results. You can see the same schema. And I'm running a little low on time here, so otherwise I would rewrite and fix, the MinIO part of it. But you get the point here. Again, curse of a live demo. Anyways, so immediate next steps that we're working with for Iceberg Go. Looking for adding more write support. We want to add in for handling partition specs, position, adding writing deletes, graceful transaction failures, and obviously the rest of the V3 features. And finally, we want to add more of the catalog support, which I already mentioned. Don't need to repeat. But also, one of the other things is that one of the reasons why I created Iceberg Go was I wanted to get more Golang into the data ecosystem. Because unlike Python, it's compiled, not interpreted. The static binaries, as opposed to C++, make it super easy to deploy and utilize. And then obviously you can leverage all this concurrency and parallelization that provides. And you can see over time, we're getting more contributors, especially more recently. More and more people are getting interested in contributing and becoming part of the Iceberg Go project, especially getting a lot of interest from AWS, MinIO, Lakekeeper, and a few other companies that developers are significantly contributing and improving. So it's happening. And if you're really interested, please, we need more contributors. Always need more contributors. It's open source projects, just the way it is. So, please contribute, or at least test it out. File issues. Tell us what it doesn't support that you need. So on and so forth. And so, thanks. That's my talk.